The most lucid image of Proxima be ever released by the James Webb Telescope provides startling new information about this potentially habitable exoplanet. Come along with us as we travel through space to solve the puzzles surrounding Proxima. B and see if it holds the potential to be the future Earth. Come on, let's go! The marvelous exoplanet, a mystery planet called Proxima Centauri, is located in the habitable zone of its star, deep within the vastness of space. Proxima Centauri b is not just any old asteroid. It's a relative of Earth. This planet, which is only 4 light years distant from Earth, is a mystery and a wonder. Is it a different Earth, one with seas and a plethora of life thriving on its surface? But there's still more. The super-Earth Proxima Centauri c is Proxima Centauri b's companion on its orbit around the red dwarf star. Who knows what further mysteries this stellar system conceals, possibly even another undiscovered companion. The energy that Proxima Centauri b receives from its star is comparable to that which our planet receives from the Sun. Does this imply that there is water, possibly even life on its surface? Exoplanets, or planets that circle stars other than the Sun, are a whole new world that we find as we travel outside of our own solar system. The cosmos contains 206 trillion stars. Thus, the possibilities of finding exoplanets are countless. Like lone space travelers, some exoplanets even cruise the universe unrestricted, unattached to any star. Proxima Centauri b is the most unusual and mysterious planet of them all. One side of the planet is probably always bathed in daylight, while the other half is in perpetual darkness. Since the planet has a year that lasts only 11 Earth days, and it is located 20 times closer to its star than Earth is to the Sun, it presents a unique dynamic. As a component of the Alpha Centauri triple star system, Proxima Centauri b revolves around the red dwarf Proxima Centauri. The closest star system to our solar system is made up of Rigil Kentaurus, also known as Centauri, Ptolemy, sometimes known as Centauri b, and Proxima Centauri, also known as Centauri c. The third brightest stars in our night sky, Rigil, Kentaurus, and Ptolemy, make up the binary Alpha Centauri of. These G and K-type stars appear as one star in the Centaurus constellation. The red dwarf star Proxima Centauri, sometimes referred to as Alpha Centauri c, is situated 0 to 1 light years away from the other two stars, or almost 13,000 times further away than Earth is from the Sun. Scottish astronomer Robert Innes discovered it in 1915, making it the star closest to Earth. Even though it is our nearest star neighbor, its apparent brightness of 11.13 much higher than the human eye limit of 6.5 means that it is invisible to the unaided eye. Proxima Centauri and other red dwarf stars are among the most productive sources of energy. Their internal convection processes keep them burning for trillions of years, even though they don't produce much energy. For a further 4 trillion years, Proxima Centauri will continue to be a main sequence star. It is still up for debate, though, whether a red dwarf star like Proxima Centauri is habitable. It is a flare star that fluctuates frequently and erratically. Its habitable zone, estimated to be between 0.023 and 0.05 for astronomical units, is much closer to it than Earth is to the Sun. Despite being in this zone, Proxima b is subjected to hundreds of times more intense UV radiation from its star than we are from ours. The life-giving chemicals could be destroyed by this strong radiation. Yet, the investigation into Proxima b's true nature continues in spite of its challenging circumstances. After multiple delays, the James Webb Space Telescope JWST was finally launched in 2018 to investigate the possibility of life on Proxima b. The telescope is capable of observing infrared light, which enables it to identify light that Proxima b may re-emit after absorbing light from its star. The capacity to recognize water or an atmosphere is essential. Proxima b may resemble Venus in having a thick, hostile atmosphere. Thus, even if it does have an atmosphere, it does not necessarily mean that life exists there. One of the JWST's limitations is that the existence of an atmosphere does not always imply life. It's possible that Proxima b has a hot, humid atmosphere that is unfit for life. Even so, if artificial light reaches 5% of the brightness of the day side, the JWST can detect it, a noteworthy ability given that Proxima b's star is far fainter than our Sun. Bright orbiting mirrors could be used by Proxima b's sentient civilization. If one exists, to reflect sunlight to the planet's night side, reaching Proxima b is difficult. The Proxima Centauri system, the closest exoplanetary system to Earth, yet it would take a spacecraft like Voyager 275,000 years to reach it. But solar sails, which speed up spacecraft by harnessing solar pressure, might cut the trip time too. Only 20 years. With this technology, the problem of running out of fuel is resolved, and interstellar travel may become possible. Additional exoplanets abound, just waiting to be found. These planets range in size and form from enormous gas giants to planets that resemble Earth, superjupiters, which dwarf even the largest planet in our solar system, are examples of gas giants. Bigger versions of planets like Jupiter and Saturn. Gas giants known as hot Jupiters orbit ferociously close to their host star, reaching temperatures high enough to melt metal. Imagine being on such a world with its violent storms and scorching temperatures up close. Proxima b's discovery has rekindled human curiosity about space travel and given us hope that we are not alone in the universe. Although the JWST has limits, its capabilities represent a major advancement in our search for the mysteries of far-off worlds. We are still traveling to Proxima b and other exoplanets because we want to learn more about and comprehend the universe. Proxima Centauri b, an exoplanet that circles the star of the same name, is one of the most fascinating discoveries in recent years. With a mass of almost 7 Earth masses, this planet is categorized as a super-Earth. Despite being near its host star, it is too far away to be considered comfortably within the habitable zone. Proxima Centauri c is a companion star of Proxima b, however, it is even farther away. This planet was found in 2020 using pre-recovery Hubble data and has an orbital period of about 5.5 Earth years. Perhaps because of a ring structure, Proxima c appears to be an extremely brilliant world. A shift in Proxima Centauri's radial velocity was noticed by scientists in 2019, which could point to the existence of another planetary companion. If verified, it will be named Proxima Centauri d and would be about the size of either Mars or Mercury. Envision a universe in which the night sky is inhabited by innumerable planets, each with a distinct composition and orbit. In addition to stars, we continue finding exoplanets, just one of the many wonders of the cosmos. Astronomers are living in an exciting period, with new discoveries being made regularly. Like the stars that light up the sky, we know exoplanets exist. Even though we don't yet have an exact count of them, exoplanets are difficult to observe and must be found using large telescopes and cutting-edge equipment. The glare of their host stars often obscures them, but with some of the greatest telescopes in the world, direct imaging of exoplanets is now feasible thanks to technological developments. An exoplanet needs to be big enough to be observed with a telescope, far enough from its host star to avoid being blinded by its glare, and young enough to be hot and visible from Earth in order to be directly imaged. These constraints limit the number of exoplanets that may be directly photographed, but offer an intriguing window into the properties and makeup of these far-off worlds. The most frequent method for finding exoplanets is by observing the changes, because in their host stars, astronomers can detect the radial velocity of a wobbling host star caused by an exoplanet's gravitational pull. The transit method, which analyzes a star's light dimming when an exoplanet passes in front of it, was employed by the Kepler Space Telescope. The size, distance, and temperature of exoplanets have all been better understood through this technique. Here are some interesting statistics. Earth-sized planets can be found in the habitable zones of almost 22% of stars similar to our Sun. 7 rocky exoplanets with water on their surfaces can be found in the TRAPPIST-1 system. Exomoons, naturally occurring satellites, can exist on exoplanets just like on planets in our solar system. We now know that exoplanets are widespread. across the universe with over 4,000 discovered so far. Many more are waiting to be found, though hot Jupiters are the easiest to detect due to their mass and fast rotation. NASA's James Webb Space Telescope is revealing the mysteries of the cosmos, uncovering previously hidden phenomena. This telescope has been collecting data and capturing images of the universe. It recently made history by discovering the first concrete evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This gas giant, located 700 light-years from a sun-like star, provides critical details about planetary composition and evolution and marks a major milestone in the search for extraterrestrial life. Additionally, a multinational team of astronomers used the telescope to inventory the coldest, deepest ice ever detected in a molecular cloud. They discovered frozen molecules such as water, carbonyl sulfide, ammonia, and methane, along with more complex organic compounds like methanol. These findings offer invaluable insight into the formation of future stars and planets.